Hi, this is a video where we're going to talk about light as made up of particles instead of a wave. So, in the early 1900s is when this started to happen, that we started to see that there were some experiments that we couldn't explain, thinking of light as a wave. One of those experiments was the photoelectric effect. The photoelectric effect is if we shine light on a metal, different types of metal this works, sometimes electrons will leave the metal or they'll get ejected or pushed off of the metal. The weird thing was in the experiment, there was a threshold frequency where this would happen. Not all color waves were able to dislodge the electrons. If we still believe that light is only a wave, then any frequency should have worked. So we then had to start looking and thinking about light differently. Sometimes we have to think about it as a particle. So light, visible light, but also every other type of wave in the electromagnetic spectrum has this dual wave particle nature. So when I ask people, I always joke, is light a wave or a particle? Your answer should be yes. It's both. It just depends on what the experiment is and how you're trying to explain it. So the photoelectric effect, when we have those waves coming in and there was a threshold frequency, so let's say this is our red wave and then this would be our blue wave. In order to explain this, we have to think about the wave not as a wave, but as made up of little bits of energy. And these are called photons. So the particle of light is called a photon, and each photon has a certain amount of energy. So some of the photons had enough energy to cause the electrons to come off. The energy of the photon, I will explain, you can calculate this with math. So thinking of light as a particle leads us to thinking about light as being quantized. And quantized means that it's a discrete, countable unit. So this here is not quantized. This would be continuous. This here is quantized. You have to have pieces. Another analogy of this is a piano. The piano keys are quantized. You play one or the other. You can't go in between, but you can, I believe, on a string instrument, play any combination of a frequency. So this is something that's very abstract and sometimes hard to understand. So I will explain it many different times, many different ways. So when we say something's quantized, it means that it has to be in pieces. So photons, those particles of light, by the way, here's another weird thing. They are considered to have no mass, but they carry a quantum of energy. So this is a silly cartoon, but it actually helps me to explain this. This would be the photon, the piece or particle of light, but it doesn't have any mass. I know, weird, right? And it's carrying a quantum or a little bundle or a piece of energy. That energy of that quantum has to be in some chunk, and that's why it's quantized, or piece, has to have energy equal to h nu. H is Planck's constant, and you don't need to memorize this. You just use a constant to help you to make an equality. And then nu, the Greek letter nu, it looks like a V, just like we did before with the frequency of light. It's frequency still of any type of light, visible or any part of the electromagnetic spectrum. So I can figure out the energy of the photon by taking Planck's constant times the frequency of the specific type of radiation.